So friends, today from this video we will be learning that why Nmos acts as a strong 0 but weak 1 and Pmos acts as a strong 1 but weak 0. So you must have heard this statement right everywhere, like Nmos acts as strong 0 but weak 1. So it's a very basic concept, and we must be knowing it, and it should be clear. Actually, you must be able to explain anyone who questions you. So that's why I'm making this video. So through few slides I will be explaining what actually it is. So now let's consider the first case. First case is Nmos acts as a strong 0 but weak 1. So why is it? Now what actually it means? Now you see, like in digital logic, 0 means logic 0. So it can be 0 volt or negative 5 volt or minus 2.5 volt, minus 1.5 volt, which are the lowest voltage, okay, VSS. And 1 means logic 1. So logic 1 can be 5 volts, 1.8, 2.5, or anything like 1.6 also, any voltage which we define. So this thing you have to clear. Now this is a basic Nmos gate. Nmos gate, this is the gate terminal, drain, source, and this is the capacitor, because every voltage which we are output voltage will has to be stored in some capacitor. So even if it's not present, we will be making a capacitor which have a capacitance C. This is the output terminal, this is the input terminal. So what is the first we will investigate, you all of you know that when VGS is greater than VT, then the Nmos will turn on, right? This is a very basic equation, fundamental equation of Nmos. And here the higher logic we are treating is as for 2.5 volts, and the lower logic as 0 volt, okay. And the threshold voltage of this Nmos is 0.7 volt, positive 0.7 volt. So whenever VGS is greater than VT, the Nmos will be on. So let's consider the first case. In the first case, I am giving logic 0, that means input voltage as 0 volt. So what is the value of VGS? The value of VGS is 0 minus 0. Definitely this is not satisfying this equation. So Nmos is off. So Nmos is off, then definitely there is no supply, I mean flow of current from VDD to this point. And we assume that initially there is the capacitance voltage is also 0. So what is the output voltage, guys? Output voltage which I am getting is 0 volt. So when I applied input as 0 volt, output which I am getting is 0 volt, which is the logic 0, okay. Now let's change the case. Let's apply logic 1 at the input terminal, that the gate terminal, this gate terminal. So when I apply logic 1 or 2.5 volts, the situation changes. How it changes? Now let's try to find what is the value of VGS. The value of VGS is 2.5 minus 0, 2.5 minus 0, that's which is greater than threshold voltage, which is 0.7 volts. So when I apply this, then this Nmos turns on, and when Nmos turns on, then the current starts flowing, passes from current passes through the channel of this Nmos, and then it reaches here, okay. And when it reaches here, it starts charging the capacitance. So you can see that it will be slowly increase from 0 to 0.5, 1, 1.5. Then what is the maximum limit? I mean, let's see the case when the voltage here, due to charging of this capacitor, reach to 1.5 volt. So the VGS value will be 2.5 minus 1.8, that is 0.7. Now it has now you can see from this equation, the threshold voltage is exactly equal to the VGS. A very small increment in the output voltage, I mean if it changes from 1.8 to 1.805, or let's say 1.9, so what will be the difference, guys? The difference will be 2.5 minus 1.8, 2.5 minus 1.9 is 0.6. So this condition will violate, and if this condition will violate, then Nmos will turn off. So Nmos will turn off. So this path will be blocked, and the voltage will be retained maximum up to 1.8 volt. So as you can see, I am giving logic 1, which is 2.5 volt, but at the output terminal I am not able to get the exact 2.5 voltage. So that's why we are saying that is weakly passes 1, because the output voltage never reaches. Let me write it. What is output voltage never reach max of logic 1, whatever it will be, maybe whatever voltage it may be 2.5, 1.8, or anything. It is lesser than the logic 1 voltage by VTP, which is the threshold voltage of Nmos. So it is not able to reach. Now again, when I flip again from logic 1 to logic 0, like 2.5 to 0, so what will happen, guys? The VGS voltage will be negative, of course the NMOS will be off. So when the NMOS will be off, this current will find a path to discharge the capacitance through this resistance, and slowly from 1.8 volt it will go to 0. So again here I gave 0 volt. I am able to get 0 volt. Logic 0, I am able to get logic 0. So strongly I am getting I am able to get logic 0, or the lowest VDD voltage. But that's not true with the logic 1 or 2.5 volts. So the conclusion is NMOS strongly passes 0 or logic 0, and weakly passes 1 or logic 1. This is the maximum VDD voltage. Don't be confused. This is the max VDD, whatever technology you are using, right? And then second statement is PMOS acts as strong 1 but weak 1. So this is the diagram of PMOS. The current flow is in this direction. Okay, so this is the gate terminal, this is the source terminal, this is tied to the highest voltage, like VDD. Let's assume it to be 2.5 volts. Okay, and this is the output terminal, this is the capacitance we have assumed. So what will happen when I will apply, and this is the equation, this is the primary equation which will be using. So for NMOS PMOS to turn on, this condition should be satisfied. VSG should be greater than equal to VTP mod. Okay, and the threshold voltage of this PMOS is minus 0.7 volt. Okay, so obviously you can see when I apply the input, when I give input 2.5 volt, output voltage was also 2.5 volt, because the current has direct path. So it will charge the capacitance to the maximum value of 2.5 volt, right? It's clear. So what's the difference, guys? The difference is 2.5 minus 2.5, that is 0 volt. 0 volt is greater than magnitude of VTP 0.5. Is this condition true? No, it's not true. That's why PMOS is off. So when PMOS is off, you don't have a path now. You don't have a path for current to flow from here to here. So when I give the input voltage as logic 1, I am getting output as also logic 1 or 2.5 volt. There is no degradation in the voltage. So that's why we can conclude that PMOS is a strong one. It passes strongly 1. But let's change the case. When the input voltage is 0 volt. When I applied the input voltage, what is the SG? VSG value is 2.5 minus 0. So it is definitely, it will make the PMOS on. So once the PMOS is on, a path will be created here, and that's why the voltage, this voltage, capacitance voltage will start to move in from this part. Okay, so when capacitor will start discharging through path 1, so up to how much value it will fall, like when it reaches a value of 0.7 volts, so VSG value will be 0.7 minus 0, that is equal to the mod of this equation. Okay, but any voltage lesser than, if it falls to 0.6 volts, so 0.6 volts minus 0, of course the input is logic 0, logic 0, so it is 0. So 0.6 minus 0, that is 0.6. this condition will be violated now, like this is 0.6 and this is 0.7. So this is one violated. So when this is violated, PMOS will turn off. So once the PMOS will turn off, this path is blocked. So maximum voltage till which it will fall from logic 1 or 2.5 volt is 0.7. So it will never reach exact 0 volt, guys, which is the lowest logic 0 voltage. Okay, it will be somewhere above, like I mean there will be a bump of 0.7 volt or whatever the threshold voltage. So so now you can understand why PMOS strongly passes 1 but weakly passes 0. So you can again take look at this diagram. 2.5 volt, I am getting 2.5 volt, but when I am giving 0, then it goes up to 0.7 volt and then stops, because after that the condition will not satisfied and this PMOS will turn off. Similarly goes with the NMOS. Thank you, guys, and stay tuned to my channel Shubham Rahi for more videos regarding VLSI, digital electronics, and analog, and STA. I will be making the videos, a whole series of it, and uploading. Thank you guys.